Good morning, students. Today we will discuss about the application of the two rules. One is clock face rules and second one is the Maxwell right and thumb rules. So we have three questions on this rules. First one is that what is the polarity of the end of the, this is the first question. So what is the polarity of the end A? End A में polarity क्या होगा, कौन से रूल से फॉलो करेगा, एंड विच वे विल द कंपास पॉइंट्स देन. और यहाँ पे एक कंपास रखा हुआ है, तो करंट जब पास करेगा तो ये कंपास का निडल जो है किस ओर डिफ्लेक्ट होगा. ये है फर्स्ट क्वेश्चन का आंसर. तो दिस इज द first you see here, as we already know that this is the clock phase rules. And what is the clock phase rules? We have already said that if the current flows in a clockwise directions, if the current flows in a clockwise direction, then that end of the circuit must be the south pole. So here you see that the current flows in that circuit is a clockwise direction. You see that there is a clock. The clock is moving in this way, so this is a clockwise direction. So this end must be the south pole. Must be the south pole. So it is a south pole. Ultimately, another end must be the north pole. So we have already knew the both of the poles of this circuit according to the clock phase rules. When it is a north pole and there is a magnetic compass, so you see that the same pole is not here, not close to each other. It means if it is a north pole, it must, there is a south, the needle of the magnetic compass must be moves away from the north pole. So the movement of the needle is in this way, because this is a north pole and this is a south pole. So the repulsion is taking place. Here is a north pole, here is a north pole, so it moves away from the, due to the repulsion it moves away from the, so the position of the needle is in this way, it moves in this direction. So this is the question of what is the polarity of A. Polarity of A is S according to the clock phase rules, and which way it will move, compass moves. So it moves away from the north pole because it is a north pole and it is also a north pole. So it repels and moves away from the north pole. And this, now second figure you saw here. So the solenoids is here, bound in a core soft iron. Will the end A be the north pole or south pole when current flows in the direction shown? You see here that it is a solenoids. The current flows in this way. You see that the current is moving from this way, originating from this point. So this is a anti-clockwise. You see that the direction is anti-clockwise, and we have already known from first application, when the direction of the current is anti-clockwise, then the pole must be the north pole. So it is anti-clockwise, so this pole must be the north pole. So it moves towards the north pole, moves to, so this first pole is a north pole. Ultimately this pole becomes south pole, because in a magnet bipolar pole is there. So when we get first pole, from the current passing from first pole and that passing through the anti-clockwise, so it is a north pole, and alternatively the second pole is a south pole. So you see here is a two examples. When the current flows in a particular circuit, you see here, you see that the current flows in a clockwise direction. If in a circuit, in a circular loop, if the current flows in a clockwise direction, then that phase must be, that end must be the south pole. and other must be the north pole. Likewise here. Here the current flows anti-clockwise direction. So the first end of the coil must be the north pole. It is also clock face rules states. So this is the second questions. In a wire, in wire A and or in a wire B. In a straight wire A, current, second questions. In a straight wire A, you see here is a straight wire A, here is straight wire B, and it work on the principle of Maxwell right and thumb rules. We already know many times that this is the Maxwell rules positions. So in first case, see that the current flows in and downwards. In second case, we see that the current flows in a upwards. When the current moves in a downwards, then what we see that? What do we see that? The curling of the finger is clockwise direction. This is the position. This is the position of the Maxwell right hand rule. So my thumbs direct the current direction of the current, and the curling of the finger shows the direction of the magnetic field. So this shows the direction. So the clockwise direction. Here you see that the clockwise direction of the magnetic field is a direction of the magnetic field when the thumb is downwards. Here you see that's the opposite. Then the current moves in this way. Thumb is upward, so that this thumb shows the direction of the current. Then this curling of the fingers. This curling of the fingers shows the direction of the magnetic field line, and it is in anti-clockwise direction. So this is some application related with the clock face rules or Maxwell right hand rules. We have many other examples. So you in a home you practice such rules. How does it apply? Because when you get the concept of these things, then it is too easy to study the magnetic effect of current very easily. Thank you.